Hello there. So far we have learned about the parameters that are used to describe motion. Then we saw the relations which relate these parameters. Then we discussed various situations and saw how those situations can be analyzed using these equations. Right. But so far we have only dealt with equations. Now motion can also be described in terms of graphs. So in this session we will learn about describing motion through graphs. The first graph that we will discuss is distance time graph. Now, before we start distance time graph, let's refresh our memories about the basic properties of a graph. So in a graph, we essentially have an x and a y axis. And the curve that is drawn depicts how y changes as we make a change in x. Or we could say that this graph that is drawn basically relates the variable on the x-axis with the variable on the y-axis. Right. So when we talk about a distance time graph, we are basically talking about a graph that will show how distance changes with change in time. So let's understand this by plotting the behavior of a particle which say moves with a constant speed of 5 meters per second. So let's see the variation of distance with time for a particle which is moving with a constant speed of 5 meters per second. So at t equal to 0, the particle, let's say, is at the origin. At t equal to 1, you can guess the particle would have moved by a distance of 5 meters. At t equal to 2, it would be at 10, and similarly t equal to 3 would give you a value of 15. Right. So first of all, I want you to notice that we are talking about one-dimensional motion. And on a 2D graph, whenever you have some other variable like time, we will always be plotting one-dimensional motion. So whenever on the x or the y axis, if you have time, the motion that is being depicted will be one-dimensional motion. Right. So let's try to plot this graph. So the distance time graph means that distance is on the y-axis and time is on the x-axis. So let's try to plot these points. The first point is 0, 0. The x-coordinate, which is time, is 0, and so is the y-coordinate, which is distance. So it starts from here. The next point has the x-coordinate of 1 and y-coordinate is 5. So let's mark these points. So this basically shows x equal to 1, 2, 3, 4, 5 onwards. And here on y, let's make smaller cuts. So now let's plot this. So these points are 5, 10, 15 and 20 respectively. So at t equal to 1, the point is at x equal to 5. At t equal to 2, it is at 10, and similarly at 3, it is at 15. So if you join these 4 points, you see you're getting a straight line. So what does this tell us? This tells us that on a distance time graph, if you have constant speed, you will have a straight line. So on a distance time graph, straight line implies constant speed. Right. Now let's talk a little more about graphs. So in a graph, if you have a line like this, the slope of this line is defined by using 2 points, and the way to do it is, at such 2 points, we will measure the distance, the horizontal distance between them, and then the change in y coordinate. So if you have a line like this, and between 2 points A and B, if you measure the change in x coordinate and the change in y coordinate, then the slope of this line slope of this line is defined as change in y by change in x. Right. Now the same thing can be represented by using the angle theta that is formed with the horizontal. If you use this angle, you can see that tan of theta here is equal to basically delta y by delta x. So slope is nothing but tan theta, where theta is the angle that this line makes with the horizontal. Now if you are not familiar with trigonometry, this may seem slightly complicated. So you can come back to this section and revise it again once you are familiar with these terms. I'm also assuming that you have the basic idea of coordinate axis. If not, I would suggest that you go to your mathematics module, study the basics of coordinate system, and then come back to this section. Right. So we know what slope is on a graph, but let's now talk about the significance of this. What happens when slope increases or decreases? So a higher slope means the line is more steep. So if I draw two lines like this, let this line be 1 and 2, you can clearly see that line 1 is more steep as compared to line 2. So from the term we have defined, we can say that slope of 1 is more than the slope of 2. Right. So now the statement that we made, that on a distance time graph a straight line implies constant speed. So we could also say that this constant speed is basically constant slope. Why do I say this? This is because if you plot a graph for a particle which is accelerated, you would see that the distance time graph would curve like this. Right. So if it curves like this, look at individual points and let's try to check their steepness. How do we do that? We will draw a tangent at each of these points. Right. Now you can see that the three different tangents that I have drawn are getting steeper, which means that the slope is increasing. Right. And the slope is increasing because as it accelerates, its speed keeps increasing. Right. So on a distance time graph, if you have a straight line, then the particle is moving with a constant speed. And if it moves with an acceleration, you would see an upward curve like this. Also, from this discussion, we can see that for a distance time graph, the slope is nothing but the speed. So in a distance time graph, slope gives speed. Let's discuss this further. On this graph, if you wish to find slope, as we have discussed, you would measure the change in x coordinate. Now on the x-axis you have time and on the y-axis you have distance. So the change in x coordinate that you are going to measure is nothing but change in time. Right? Because you have time on the x-axis. So if you measure change on the x-axis, it is basically giving you the change in time. Right? Similarly, when you measure the change along y-axis, what you are measuring is the change in distance, which is basically the distance moved from this point to that point. Right? Because y coordinate is giving us the distance. So this change in y coordinate is nothing but the distance moved. So think about it. When you find slope which is delta y by delta x, in this case becomes delta s by delta t. And what is the distance covered by time taken? It is nothing but speed. Right? That is why we said that slope of a distance time graph gives us speed. Right. Right. So from this entire discussion, the key things that you should remember is that in a distance time graph, if you see a straight line, it tells you that the particle moves with a constant speed. Also, you should remember that slope of a distance time graph gives you speed. So, let me draw a graph for you and let's make some inferences based on that. So, say the graph goes something like this. Can you think of the points where the speed is maximum? I mean, let's compare a few points. Let's say this is point A. Let's compare this to a point B and compare that further to this point C. Which of the 3 points A, B or C has maximum speed? If we are to make this inference from this distance time graph, that which of the points from A, B and C has the maximum speed, how should we do that? Well, you should imagine a tangent drawn at A, B and C and then try to see which of these lines is the steepest. I hope you can see that the tangent at C is the steepest, and that is why the speed at point C is the maximum. Right, same is the case we had seen in this graph. As the particle moved, we saw that the slope of the tangent kept on increasing, indicating that the speed of this particle is increasing. Right, so let's now move to displacement time graph. Now that we understand distance time graph, let's see the difference between a distance time and a displacement time graph. Right, so in a displacement time graph, we'll basically have displacement on the y-axis and time on the x-axis. Right, so can you think of the differences that will be there between a distance time and a displacement time graph? Well, let's try to think about it. The first thing that we know is that in a distance time graph, the slope gives us speed. So in case of a displacement time graph, slope will give us velocity. For the same reason, that is, when you measure slope for a displacement time graph, you will measure change in y by change in x, which in this case will translate to change in displacement by change in time, which basically gives you velocity. Right. The second important difference is that in a displacement time graph, the curve can fall below its current level. That means that the graph can go up and then come down and then go up again. Whereas in distance time graph, the curve can never come to any point which is below the previous positions. Why is that? Because as a particle moves, its distance always increases. It can never decrease. Whereas displacement of a particle can increase or decrease depending on whether it is continuing in the direction it was initially moving in or if it is moving backwards. Right. So, in a displacement time graph, the slope gives us velocity and this graph can go up and come down. Right. So, let's try to see this difference by taking a small example. Let's say a particle goes from point A to point B at a constant speed of 10 meters per second, and then it comes back to point A. Right. So if you draw a distance time graph, try to think about how it would look. If we draw a distance time graph, then since the speed is constant, we know we'll get a straight line with a slope which is equal to 10. So this graph would look something like this. So this is point A and this is point B, the point corresponding to B. Right. And then when it moves from B to A again, let's take this distance as 50 meters. That will help us understand. So if this is 50 meters and the speed is 10, I hope you can figure out that it must have taken 5 seconds to reach point B. So we know that the x coordinate is 5 and the y coordinate is 50. Right. So this is the first interval while it moved from A to B. Then it goes from B to A when it covers another 50 meters with the same speed. So it will again take 5 more seconds. So at t equal to 10 seconds, it would have covered 50 plus 50, which is 100 meters. So the total distance becomes 100 meters. So if I extend this line, this is again the point A. So notice this, that the motion is in one dimension. This is the motion. These arrows represent the motion. But we are plotting that in a two-dimensional graph. This is because on the second axis we have time. Right. So this is what the distance time graph for this motion looks like. Now let's think about the displacement time graph. So while it moves from A to B, this is displacement. Let me put this vector arrow to distinguish it from distance time graph. So when it goes from A to B, it once again takes 5 seconds to reach a point where displacement is 50. So this first half is same for the displacement time graph. But in the second half, when it starts to move backwards, the displacement starts to decrease. And when it finally reaches the point A again, it has come back to 0. So this graph would come down and end here. So this is point A again. So this shows the displacement time graph depicting this motion, and this right here is the distance time graph. Right. So in the next session, we will talk about speed time and velocity time graphs. Thank you.